Continuing with lesson 4.4 on trigonometric functions of any angle. In example 5, we're trying to find the reference angle theta prime for each angle. So if theta is 590 degrees, you're going to start at our usual starting point. And I've already subtracted 360 because you're going to go around one full rotation, so that's 360 degrees. And then what's left over is 230 degrees. This is 180, and then there's a 50-degree difference after that. So 230 minus 180 is 50 degrees, so that's my reference angle. If theta is 15 pi over 4, since that's more than a full rotation, I would go ahead and subtract 2 pi. And so to do that, I have to get a common denominator. So multiply by 4 on the top and on the bottom. So that's 15 minus 8, which is 7 pi over 4. And so pi is a half turn. If I break it up into 4 parts, it's going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is equal to pi. Then 5 pi over 4, 6 pi over 4, 7 pi over 4. So see, I'm breaking up this angle, this half turn, into 4 parts. 1, 2, 3, 4. Not drawn to scale. Then I keep going, and that's how I get here. The reference angle is always made with the x-axis. So what's left then, because this was 1 pi over 4, 2, 3, 4, 5, 6, 7, pi over 4 is here. 1 more pi over 4 would be 8 pi over 4, which would take us back to 2 pi. So my reference angle is what's left, pi over 4. If I have negative 13 pi over 3, I'm going in a clockwise direction. So I'm going this way. So because this is a negative number, I'm going to add 2 pi, and that's going to give us negative 7 pi over 3. You have to find the common denominator, so multiply by 3 on the top and bottom, and that's 6. And so negative 13 plus 6 is negative 7. Continue to add 2 pi until you can't do it anymore, and then it's negative pi over 3. So negative just tells me it's turning in a clockwise direction, so this angle is pi over 3. That's called my reference angle. So you can use reference angles to find exact values of the following trigonometric functions. So exact values mean you want either a fraction or an integer. No decimal points. The sine of 330 degrees. So always start here. Go around. A full turn would be 360. So if I stop at 330, there's a 30-degree difference between 330 and 360. So what I'm really looking for is the sine of 30. It's going to be negative because it's in quadrant 4, and we said the y coordinates, here's the y-axis, these are negative numbers. So it's going to be negative. Now where am I getting 1/2 from? You can go back to your 30, 60, 90 right triangle that we talked about in a previous lesson. The shortest side is opposite the smallest angle, 1. The longest side is the hypotenuse, 2. The other side is radical 3. So the sine of 30 is the opposite over the hypotenuse. To find the tangent of 7 pi over 4, we're going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That leaves me with a leftover pi over 4 to get to the x-axis. So that's my reference angle. So I want the tangent of pi over 4. So the tangent of pi over 4 is also 45 degrees, if it helps you to think about it that way. I can get that by multiplying by 180 degrees over pi. The pi's cancel out, and that's where I'm getting 45 degrees. Think about the tangent of 45 degrees. You can set up a 45, 45, 90 triangle. Should be isosceles, which means that this side is equal to this side. The tangent is opposite over the adjacent, TOA. So that would be 1, but I'm making it negative because in this quadrant, tangent is going to be negative because the slope of the line is negative. Also, because tangent is sine over cosine, or y over x, the y coordinate is negative, the x coordinate is positive. So a negative divided by a positive is a negative. The secant of negative pi over 3. Negative means I'm turning this way. I converted pi over 3 to 60 degrees by multiplying by 180 degrees over pi. That's how I'm getting the 60. So it's like a turn of negative 60. So go to your triangle here. Secant is the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, then you would use hypotenuse over adjacent. So the positive 1/2, that's your cosine. You want to flip that. This is the cosine, and it's positive because the x coordinates are positive. You want to flip that, and you want to use 2 over 1, the hypotenuse over the adjacent, which is just positive 2. The cosine of 19 pi over 6, first subtract 2 pi to get it down, so you're eliminating the possibility of those turns. It goes around, and then it ends up. So it's going to go around 1 time, and so that's why I took off the 2 pi. Then it's going to keep going and finding a common denominator, so multiply by 6. That's 12. 19 minus 12, that's 7 pi over 6. So remember, here's where you break it up into 6 parts. So it's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6 lands you here. That gives you a leftover angle of pi over 6, which is also 30 degrees. So it's helpful to convert the radians into degrees because then you can go back and use this triangle. And if we want the cosine of 30, it's going to be the adjacent over the hypotenuse. So that's where I'm getting radical 3 over 2. And it's negative because the x coordinates are negative. The sine of negative 22 pi over 3, you're going to keep adding 2 pi until you get this number, negative 4 pi over 3. So keep adding 2 pi, which after you find a common denominator, 6 pi over 3. So that's going to be negative 16, add it again, that's negative 10, add it again, that's negative 4. So each time I add 2 pi, I'm just adding a rotation, or actually I'm going this way. So dividing this pi into 3 parts, 1 pi over 3, 2 pi over 3, 3 pi over 3, all negative because I'm turning clockwise, 4 pi over 3, that leaves me a leftover pi over 3. Pi over 3 is the same as 60 degrees. So I'm looking for the sine of 60 degrees and go back up to this triangle. Here's 60 degrees. The sine is the opposite over the hypotenuse. So it's it's positive, radical 3 over 2 because the y coordinates are positive here.